Hey everybody, I'm going to do a quick tutorial on calculations with parallel circuits. We're starting with this circuit here, which is powered by an 8-volt battery. We have one 4-ohm resistor, and that is in parallel with two other resistors, an 8-ohm resistor and a 12-ohm resistor. So again, this is in parallel with these two. These two are in series with each other, but they are in parallel with this bulb here. So we're going to break this into two separate series loops. So it is a parallel circuit, but we can break it into series circuits, and those are a little bit easier to deal with. So our first loop we're going to say is this loop here, and that is the one that includes the 4-ohm resistor. And the second loop will be the other loop, which includes the other two bulbs, the 8-ohm and 12-ohm bulbs. And we're going to do these separately. So loop 1 we'll start with, and that's the 4-ohm resistor, 4-ohm bulb loop. We know that in a parallel circuit, each loop is going to get the same voltage and the voltage of the battery. And so we start with that, 8 volts for that loop. The total resistance of that series loop is going to be the sum of all of the resistors along that loop. And since it's only going to be this 4-ohm resistor, well, that's your total resistance for loop 1. So the current, we just need to use Ohm's law, and that is going to be I equals V over R, which is 8 over 4, giving us a total current of 2 amps. So we can fill that in there. And I'm going to get rid of this calculation so it doesn't get too messy here. There we go. All right, now for the bulb itself, we can do some calculations, and to make this simpler and easier to look at, I'm going to copy these up to there. So there's our resistance, 4 ohms. Now, because this is the only resistor, it makes this one a little bit easy, but we're going to do it as if we didn't know that. So the current through this, we know the current through any series circuit is the same all the way through the series circuit, and it's going to be 2 amps. Now, using Ohm's law again, if I want to find the voltage drop across this bulb, I just need to multiply the current times the resistance, and that's going to give me that voltage drop, which is 2 times 4, 8 volts. Now this is easy because being the only resistor, we already knew that it was going to get the full voltage of this loop, that 8 volts. And so this is kind of just a double check that, hey, look, we're right. All right, so loop 2, a little more complicated because there's 2 resistors now, but really not that bad. Same thing as last time. We know that this loop is also getting 8 volts. And total resistance, we calculate the same way. We take the sum of the resistors, so it's going to be 8 plus 12. And that gives us 20 total ohms of resistance. So using Ohm's law once again, I is equal to V over R. Our current through this particular loop is going to be 8 volts over 20 ohms, and that gives us 0.4 amps of current. 0.4 amps of current. And like before, I'm going to go ahead and get rid of this so it doesn't get too cluttered here. All right, and so we are going to do some calculations for these bulbs now. And I'm going to go ahead and move my labels up to those bulbs just so it's easier to track and easier to look at. There we go. It's always a good thing to write everything down, which variables you're working with. Just makes things easier, makes for less mistakes. So keep that in mind. So again, being a series loop, we're still working with this loop 2 here. It is a series loop. It's one pathway. And so that means, well, if the current is for the total loop is 0.4 amps, it's 0.4 amps everywhere. So for both of these, we can fill in 0.4 amps because we know they are both getting that same current. And using Ohm's law, we can do quick calculations to figure out the voltage drop across these bulbs. So for the bulb up here, we take 0.4 times 8. And that gives us 3.2 volts across that bulb. And for the other one, 0.4 times 12, that gives us 4.8 volts across that bulb. And a quick double check, if we want to make sure that we're right, we know that the total voltage to this loop is 8 volts. That means the voltage drops across all of our resistors should total 8. And if we add 3.2 plus 4.8, we do get 8 volts, so that is correct. Now finally, the total circuit information. For this circuit, we know it's an 8-volt battery. That's our total circuit voltage. For our current, we just need to take the total current that the two loops draw, because the battery has to supply both the current for loop 1 and the current for loop 2, and so we add them together to find out the total current that the battery has to supply. In this case, 2 plus 0.4 is 2.4 amps. And once again, using Ohm's law, R being equal to V over I, that's going to give us 8 volts divided by 2.4 amps for a total resistance of 3.33 ohms. All right, there we go, and I'll get rid of that. So we have our uncluttered final responses here. And there it is. That's all of the voltage, currents, and resistance for the entire circuit, the loops, and the individual resistors, the bulbs. If you have any further questions, do not hesitate to ask your teacher. Thanks for watching. Have a good one.